Hello, fellow chemistry people. Um, I am going to do a problem about how to find molarity, how to find the molarity of a diluted solution. So there are a couple of things that I should probably explain before completing this problem. So the first thing I'm going to explain is going to be off to the side. So whenever you hear about molarity, written as so, molarity, it can also be abbreviated as big M. Molarity is equal to moles over liter. So that is molarity for you. And this is very useful when it comes to converting. So like how many liters or how many moles are in a certain solution and so forth. It comes in very handy to know this information. And then for this problem, there are other conversions to do as well. Since molarity, whenever it's mentioned in a problem, it's moles over liter. Note that in the problem given, that it has your values in milliliters. So what I'm going to do is I'm going to convert the milliliters, or for short, I'm going to say mils. I'm going to convert the mils to liters. So a simple way to do that is to move the decimal place 3 times, but I'm going to actually do all the math just to show that, like, I'm going to write all the conversions out. So note that 1,000 milliliters is equivalent to 1 liter. So that'll come in handy when I'm doing these problems. And I'm going to change up my color a little bit. So I'm going to do this in purple. Okay, so what I'm going to do is I'm going to convert the mils. So I'm going to convert this number and this number so that we have all our values in the same units. So 37.0 milliliters. To change that to liters, you can use this conversion. So you know that 1,000 milliliters is in 1 liter. So by doing this, you cancel out your units of milliliters and you end up with liters at the top. So this is pretty much the same as if you were to move the decimal place 3 times to the left. So you're going to end up with 0.037 liters. So you have that. And then convert your 150 mils to liters. So you do the same thing, 1,000 mils for 1 liter. Your milliliters cancel out. You end up with 0.15 liters. Or actually, I should put the 0 there. But yeah, so these are your two values, just changed to liters. And then what you can do, see, you have to know what you're trying to find. So you're given this solution. So note that you're given 37 mils of a 0.25 molarity solution of potassium chloride. Note that potassium chloride is written as KCl. So what I would do first is find the moles of the potassium chloride you have. Because whenever you're diluting a solution, I picture it like as if you're diluting Gatorade or something, but just to be all scientific, let's say you have a beaker, and then it's filled, let's see, you have like the KCl or whatever, and it's like in the solution, right? And then let's say you were to add like H2O, right? You're adding like tons of water to this. But let's say, what is it? You have your beaker filled up to that 37 mil mark, right? So the amount of moles of potassium chloride you have will not change. What's changing is your volume. That's what's changing. The amount of moles of potassium chloride that you have is not changing. So that's why I said, like, I think about Gatorade whenever I dilute Gatorade, because sometimes I do that because it's too sweet or sugary. Uh, so the way I think of it is like whenever you dilute something, you're not changing the amount of Gatorade necessarily because you still have that same amount. So you still have the same amount of the potassium chloride in it, but you're just diluting it. You're adding, your volume is increasing, but the actual content, the substance in there, that didn't change. So, um, anyways, aside from that little lecture, I'm going to do the work over here. So, what I'm going to do, like I said, I'm going to find the moles of potassium chloride. So so I guess you can count this as your first step once you have converted everything. So find moles of KCl, aka potassium chloride. So to do that, you calculate with the information that you're given. So you have your, God, why is it still popping? Okay, so you have 0.25 molarity potassium chloride, right? But the way I would write it, so that you can see the units cancel, is moles over liter, as you can see here. That's why it comes in handy, so that you know your units, because you're going to multiply this to the 37, the point, the 0.037 liters, so that you cancel out your liters at the bottom, and then you end up getting your moles. So multiply by 0.037 liters. As you can see, your liters cancel out. You end up with moles. You should end up getting 0. 00925. And that is your moles of potassium chloride. Alright, so you end up with your moles. So that's the actual amount of potassium chloride in your solution, right? So you're finding out the molarity in for the diluted solution. So what the second step, so find molarity of diluted, so I'm going to just abbreviate here. So since molarity, note that it's moles over liter again, so just take the 0.0000925 moles that we just calculated from the first step, and you divide that by your new volume. So your new volume is that 0.15 liters. So divide by 0.15 liters. Okay, here. Dumb pen. Okay. So once you do that, you get your molarity of the diluted solution finally. So after rounding, you should get 0.0617 moles over liter, or molarity of potassium chloride. So there you go. I hope that was helpful. I know my explanation Well, hopefully the explanation makes sense to you as far as going from like one solution to another whenever you're trying to calculate for a diluted solution. So I hope that this makes sense. Excuse my horrible handwriting. I'm still trying to get used to this pen. Yeah, so hope you learned something. Good luck studying. And that'll be all. Toodles.